This is the CSI 3450 final project by Eric Chan and Emily Locke. We've put together a simple airline database logging passengers and their relevant flight information, including booking, flight, and bags. Our target audience is considerably large, as our database can be used in an application designed for all adult airline passengers. Our database would be useful in an application that allows users to buy flight tickets and then view information about their flight. This is a simple UI that shows what type of information our database contains, and what that information might look like displayed to a user in an airline or ticket purchasing application. We've categorized it into a section for the user profile, the order status, and the boarding pass information. This is our EER diagram showing the 5 tables that we use to build our database. You can see the relationships between the tables and that many fields are required in multiple tables. For example, the passenger ID needs to be referenced in the passengers, booking, and bags tables in order to accurately track these separate items for a single user. Here's our flight table. This displays information about the flight itself. So we have the flight number, the ID of the aircraft, departure information like the airport, gate, and time, and the same information for the destination. This is our bags table showing the bag ID, the ID of the passengers who checked the bags, the flight number that the bags will be on, the current bag status, and the user's phone numbers and email addresses.
Hi, I'm Eric, and I'm going to be continuing on from here. Here we have our booking table. This is going to be the primary table for our database, as you can see from the 50 rows here. This table includes a row for booking number, or a column for booking number, sorry. These booking numbers do not have to be unique, as each booking number can be tied to multiple passengers, or tickets. Each passenger will have a passenger ID. These will be unique, and as this row will be used for the primary key for this table. This table also includes the flight number, a plane ID for said flight, so which plane will fly that flight. Bag IDs are tagged in the booking and are linked to each specific passenger, and then seat number is also linked to each specific passenger. So each passenger will have a unique bag ID and seat number. Our next table is the passengers table. This table has 30 rows, uses passenger ID as a primary key, and these are linked to the passenger IDs from the booking table. For reference, we also included their booking numbers and flight numbers, and then we follow up with columns for the first name of a passenger, last name, their street address, the city that they live in, state, country, and then columns for phone numbers and email addresses, which can be used which can be referred to by the bag ID or bags table in order to link them to specific passengers in the event a bag gets lost. And our last table was the payment table. Payment table uses booking numbers, which refer to the booking numbers from the booking table. We include a column for merchant IDs, so which credit card they used to pay for it. The payment ID, so the authorization for that specific payment, for that specific vendor, sorry. The price for that booking, and the status of the payment. In the event that a booking has not paid yet, these 3 columns, merchant ID, payment ID, and price, can be blank, in which case the payment status would be recorded as not paid. Here's our select query with an order by statement. We selected last name from passengers and ordered it by last name descending. So here we have the last names, 30 rows, because there were only 30 rows in the passenger table. And all the last names are in descending order. starting with Y and going to L and beyond. And here we have a select with where query. We selected the same data, last name from passengers, where the last name is O and beyond. The first letter of the last name is O and beyond. So we have 10 rows returned. We started with a last name that begins with O, and all of the last names after it, after the letter O. Here's our delete query. We deleted from the booking table any booking number, any booking where booking number was 10057. As you can see before, there are 2 rows with that. And then after the delete query is passed, there are no more booking numbers 10057, and passengers are down to 48. Here's our update query. We updated the seat number of passenger number 48 from J3 to K5, and as you can see before and after, we affected that one column, or one row for that one column, for that passenger. And our insert query, we reinserted the 49th passenger with booking number 10057 and included the relevant flight number, plane ID, bag ID, and seat. As you can see now, passenger 49 was given seat J3. Here's our inner join. We selected first and last name and bag ID. First and last name from the passengers table, bag ID from the booking table, and we linked them via passenger ID in both tables. As such, each passenger was linked with their specific bag, and given that we only have 30 passengers, only 30 rows were returned, so only the first 30 bags were returned. Here's our outer join query. We used a right join for the same data, first and last name from passengers, bag ID from booking, but now we returned all 49 bags, but given that we only have 30 rows for the passengers, these last 19 bags do not have passengers associated with them.
These are a couple of aggregate function queries where we calculated the sum of the price column from the payment table to get a total number paid by passengers for this flight, as well as the count of the bag ID column to get a total number of bags checked by passengers onto this flight. This query gets all columns from the passengers table, groups them by their booking number, and then selects only those with the passenger ID of 10 or less. This string function query selects the name of passengers from the passengers table and concatenates their address fields to form a single address column. This numeric query rounds the price column from the payment table. This date function query modifies the departure and arrival time columns to display in a 12-hour format.
So to summarize, we have made an airline database for various different airlines to be able to keep track of passengers and bookings. We demonstrated a front-end UI, a demo front-end UI of how our database could be presented, and the ER diagram of the relationships between our database tables. Those tables were bookings, which was our primary table, passengers for passenger information, bags, tracking checked bags, payments for the payment state of bookings and flights, and we also demonstrated various simple and complex queries. Do we have any questions?